All right, this is the last review that we are going to do. That will be required. We will provide a Chapter 12 review for those of you that were a little shaky on some of that material. For this video, we're going to review simplifying radicals, and we're going to review solving radical equations, Pythagorean theorem, and distance and midpoint formula. There's a lot of information in the simplifying radicals, and if you'll remember correctly, we did 3 days of that. So if this is not enough review for you, you're going to want to go back and rewatch those videos that we did when we learned Chapter 11. And those are on Fusion and on YouTube, okay? So let's go ahead and start. Remember, when we have the square root of 50, we're asking ourselves what perfect square goes into 50. Hopefully we're remembering easily that that's 25, so we break that number down to the square root of 25 times 2. From there, we can break it down even further. The square root of 25 times the square root of 2. And from here, this is where we then actually take the square root of 25. The square root of 25 is 5. The square root of 2 is not a perfect square, so we leave it as 5 root 2. And that's going to go ahead and be our answer. So that's our most basic example. Let's go ahead and talk about what happens when we have variables and numbers all underneath. So when we have our 5 terms, when we have our 4 different things that we're multiplying underneath our radical sign, we're going to go ahead and break it into 27, the square root of x to the 5th, the square root of y to the 2nd, and the square root of z to the 7th. You'll remember that we want to break apart each separately and then write them all as one final answer. So the square root of 27, 9 goes into that, so that becomes 9 times 3, and then that's 3 root 3. We can then look at the square root of x to the 5th. If you'll remember, even exponents are perfect squares, so we're going to break that down to x to the 4th times the square root of x, or x to the 1st. Square root of x to the 4th, our perfect square becomes x squared. The square root of x stays underneath the radical sign. Y squared is a perfect square, so remember we divide it by 2. 2 divided by 2 is 1, so this just simplifies to y. Notice I'm writing it without a radical sign because it's now, we've taken the square root. When we get to z to the 7th, again we break that down to z to the 6th times the square root of z. To take the square root of z to the 6th, 6 divided by 2 is 3, so we have z to the 3rd, square root of z. Now, this answer, I guess, is all right, but this looks like a disaster. So everything that's on the outside stays on the outside, so 3x squared y, z to the 3rd, and then everything that's inside of the square root will stay underneath the square root, 3x z. We look underneath the square root sign, there's nothing else that can be simplified, so this right here is our final answer. Okay, when we're talking about addition, remember we think of square roots as terms. So when we look at 2 root 6 plus 8 root 6, they are like terms, they both have a square root of 6. So we'll just add our numbers in front. We have 2 square root of 6 plus 8 square root of 6 is going to be 10 square roots of 6. Now I remember how much frustration we had when we learned these problems. If we look, we have 3 problems right here, and we have a significantly different amount of work for each problem. So you really have to look at each problem and apply what you know. Let's go ahead and look at the next one. So we're looking at a multiplication problem. We're multiplying 2 things underneath the square root, so we'll go ahead and multiply them. 8 times 6 gives us 48. X to the 3rd times x to the 3rd is x to the 6th. Now we're going to break these into our 2 separate problems. The square root of 48 and the square root of x to the 6th. Now, the square root of x to the 6th is a perfect square because it's an even exponent. So I'm just going to chop that in half and start with my variable. X to the 3rd has come out, and I'm done with that now. Square root of 48, what goes in there? That's a perfect square. 4, obviously, but that's 4 times 12. We still have another perfect square that goes into 12, so we're going to want to pick the largest perfect square that goes into 48, which is 16. So we're going to break this down to 16 times 3. The square root of 16 is 4. Square root of 3 is the square root of 3. Again, this answer is kind of messy looking, so let's do a rewrite as 4x to the 3rd root 3. Whoops. Goodness, it's Friday. Okay, square root of 3. So here is our answer. All right, let's talk about a distributive property 1. Distribute. So when I'm doing 2 root 3 times 4 root 2, I'll show you the distributive property way, and then Cash does that box, so we'll kind of talk about that as well. So the distributive property way, 2 times 4 is 8. The root 3 times root 2 is the square root of 6 plus 2 times 7 is 14, and the root 3 stays on the outside. Okay, so that's going to go ahead and be our answer. And then I think the box, you do 2 root 3, and then you put the other numbers up here. And then you put the products underneath here. So 8 root 6, and then 14 root 3. And then you can go ahead and conclude that your answer is 8 root 6 plus 14 root 3. Either way, you're going to go ahead and get the same answer. All right, looking at whatever number we're on here, if we're going to go ahead and we're going to use FOIL, we can go ahead and we can FOIL if you choose to, or remember that box method. And for those of my students that were not lucky enough to have Miss Cash, let's do a quick refresher. It doesn't matter which term you put on which side, you just need to make sure that you're remembering your signs, okay? So then 2 root 3 times root 3 is 2 root 9. Root 3 times negative 1 is negative 1 root 3, or negative root 3. 5 times 2 root 3 is 10 root 3. And 5 times negative 1 is negative 5. Now we need to reduce and switch some stuff up in here. Square root of 9 is 3. So 2 times 3, this box is 6 here. And then we can go ahead and combine our like terms. So 10 root 3 minus 1 root 3 is 9 root 3. And then our other like terms are these right here, 6 and negative 5. That'll combine to be negative 1. So here we have our solution as 9 root 3 minus 1. Onward. Okay, when we talk about division, remember our one rule, we cannot have a square root in the denominator. So we're going to simplify, we're going to rationalize the denominator by multiplying both of these by the square root of 7. So we have 3 root 7 in the numerator. If you don't remember this rule, that's multiplying a square root by itself eliminates the square root sign. We'll do the long way. Root 7 times root 7 is the square root of 49. The square root of 49 just simplifies to 7 though. Now before we circle our answer, we're looking at 3 and 7. Those are numbers outside of the square root. Can we simplify 3 7s? Obviously we cannot. They're both prime numbers, so there is our answer there. I threw this middle one up there just to kind of remind you when we're taking the square root of a fraction, that's the same thing as taking the square root of the numerator and the square root of the denominator. So we're going to have to get rid of that square root sign in the denominator. Now before you go multiplying by the square root of 4 times over the square root of 4, square root of 4 is a perfect square. So we're just going to go ahead and simplify that to root 3. The square root of 4 is 2. There's nothing we can simplify out of the square root of 3. We don't have a square root in a denominator. There's nothing we can reduce down, so this is our final answer here. I'm going to move some stuff over here because this next one is a little bit more work here. So let's group these together and then shrink it down. There we go. Okay, when we look here at number last of our square root signs, remember we can't have the square root in the denominator. We learn to get rid of a binomial in the denominator, what we can do is multiply by the conjugate. And remember, the conjugate means for this one, we will do 1 minus the square root of 2. Kind of like the difference of squares, now we're going to eliminate the middle terms. So for our numerator, we're going to do 4 times 1 minus root 2. In our denominator, 1 plus root 2, 1 minus root 2. So for our numerator, we can go ahead and distribute. So we'll have 4 minus 4 root 2. And for our denominator, we're going to FOIL. I'm going to use the FOIL method on this one instead of the box method just to give you an example of a reminder of each of them. So when we do 1 plus root 2 times 1 minus root 2, it helps to draw your arrows. 1 times 1 is 1, minus 1 root 2, plus 1 root 2, minus the square root of 2 times 2 will give us 4 underneath our square root sign. Our middle terms eliminate themselves, and we're left with 1 minus 2, because our square root of 4 becomes 2. So 1 minus 2 is negative 1, and that's going to be our denominator. Now this is an acceptable answer, but if we're looking for a multiple choice answer, we're not going to probably see this as an option. So we're going to divide both of these terms by -1. 4 divided by -1 is -4. -4 root 2 divided by -1 will be +4 root 2. And this right here is going to be our final answer for this one. Okay, that was by far the most difficult section of the chapter, so let's go ahead and move on to what we thought was quite a bit easier when we learned it. All right, we're going to now talk about solving radical equations. Remember, we're trying to get the thing that is being taken the square root, we're trying to get the radical sign by itself. So when we look at this one, 6 times the square root of x minus 30, we're going to move the 30 first to the other side. So we have 6 root x is equal to 30. And now we're trying to get the square root by itself again, so we divide by 6. So we get the square root of x is equal to 5. Not by itself yet. Remember, to undo taking the square root of something, we're going to square both sides. We square both sides, x squared is equal to 25. Now, remember from this section, what we need to always make sure that we do is we need to check our solution. Because sometimes when we have taken a square root, remember we can't square root a negative number, so if we need to, we might have to eliminate some of the answers called an extraneous solution. So I'm going to remind you of how to check with your work here. So you plug this back in right here. 6 times the square root of 25 minus 30. And we want to know if that's equal to 0. So 6 square root of 25 aside. 6 times 5 is 30 minus 30. We do in fact have that 0 is equal to 0. So this works out. So what I want you to do, we want you to try the next 3 on your own, and so we're going to go over those on whatever day, Tuesday it'll be, and then we'll figure out what we still need to review from solving radical equations. Before we finish the video, we want to make sure that you get a couple of formulas written down. Pythagorean theorem. Remember, this is what we're using right triangles. Right triangles obviously have a right angle in them, and the formula is pretty good. So we're going to go ahead, let's draw ourselves a sketch of a right triangle. Remember, side A and side B are our legs. That's the triangle, they're leg and leg. And then side C, on purple now, is our hypotenuse. Please go ahead and take note that our hypotenuse is always the longest side. That's one real easy way to check that you have a correct answer, because if you have something that is not the longest side, then you made a mistake somewhere to find that hypotenuse. So the Pythagorean theorem actually is a squared plus b squared is equal to c squared. This is used to find our unjoined side length. And the converse of that, we'll talk more about that in geometry quite a bit actually at the beginning. The converse is when we kind of flip it around. And so we're saying if we square the 2 legs, the 2 shoulder sides, and that equals the square of the 3rd side, then we have a right triangle. A right triangle. And this is a really nice question to ask, and we'll give you 3 side lengths and say can the side lengths 3, 4, and 5 form a right triangle? So then you'll take them, square them, put them into the Pythagorean theorem. If it's true, then yes, it can form a right triangle. And the last 2 formulas we learned from chapter 11 were distance and midpoint. So remember that distance formula is derived from the Pythagorean theorem. So our distance formula, that's going to be when we have 2 ordered pairs. And then we just take and we plug that in to our formula. Our formula right here is the square root. We take the difference of 2 x coordinates, we square that, and we add that to the difference of the y coordinates, and square that. So this right here is our distance formula. This will be a helpful thing to have written down if you're not going to remember it. And then our midpoint formula, that's again also when we have 2 ordered pairs. I kind of think of it as taking the average. So we're adding the 2 x coordinates together, that's an x, sorry. We divide it by 2, and then we add the 2 y coordinates together, and we divide those by 2, and that ends up giving us our midpoint. Okay? Make sure that you come on Tuesday with any questions from chapter 11. Now remember, this chapter, we only did a couple of sections out of it, but this took us quite a bit of time to get through, so go back and review those videos. Bye-bye!